Hello folks, so we're going to be focusing on the unit circle, right? And we're going to try to draw a connection between why we've been talking about triangles and now we're suddenly talking about circles, right? Doesn't seem to make a lot of sense. So we're going to try to create a connection between triangles and circles because one cannot exist without the other. So just to refresh, right, we talked about the different trig functions that we work with within trig. And so if we're dealing with sine of theta, right? So if theta is our reference angle right over here, we know that our trig ratio for sine is always going to be opposite over hypotenuse. And just to refresh, right, we're using a right triangle for this. You can do law of sines, law of cosines for things that are not right triangles, but for this case, we're dealing with right triangles only. Cosine, right, we're dealing with adjacent over hypotenuse. Tan, we're dealing with opposite over opposite over adjacent. And then for cosecant, secant, and cotangent, right, we're just taking our original three and just flipping them, right? So they're not inverses, but I like to call them inverses. So cosecant of theta is going to be hypotenuse over opposite. Secant of theta is going to be hypotenuse over adjacent. And then cotangent is going to be adjacent over opposite, right? And then one way that we can kind of remember the three OG trig functions is by this acronym SOHCAHTOA, right? And so we can use SOHCAHTOA to tell us sine is opposite hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, right? And so these trig ratios are going to be really, really important moving forward because we're going to use these as the basis of how we think about the unit circle. All right, so I've been talking about the unit circle a lot. What is it, right? The whole reason why we talk about the unit circle is so that we can understand trig functions a little bit better, because sometimes trig functions are called circular functions, and this is because they're derived from something called the unit circle, right? So everything that we're doing with these triangles is actually derived from a circle. And so the unit circle is a circle with a center of 0, 0. Right? It's at the origin, and our radius is 1 unit wide or 1 unit long. So that means that if we were to take the equation of a circle, right, that we learned back in geometry or in Algebra 1, right, we can substitute in our h and k values, so our center coordinate values, and our radius value. So we can do x minus 0, because 0 is the x coordinate for the center of our circle, plus y minus 0, because 0 is the y coordinate for the center of our circle, right? We're going to square that as well, and we're going to set it equal to 1 squared, because when we're working with the unit circle, our radius is 1. So let me just simplify that a little bit. Something minus 0 is always just going to equal the value itself, right? So this is really the same as x squared plus y squared, and that's equal to 1 squared, which is just 1, right? So we can always generalize the equation of our unit circle as x squared plus y squared equals 1 based on the equation of that circle. Okay, but what does that have to do with triangles? Like, why am I dealing with trig? We called that the basis of studying triangles, and like, why am I dealing with circles now, right? So the reason why we're dealing with circles, if we were originally studying triangles, is because there's an inherent link between the unit circle and the Pythagorean theorem. So let's say that I have my unit circle right over here, right? So if I were to draw any radius from the center to a point on the circle, right, that length is going to be 1 because my radius is 1, right? And so if I were to draw that radius, right, I know that I'm moving x directions to the right and y directions up and down, right? It doesn't have to be specifically up or down or right or left, right? But for this general example, I'm moving some horizontal distance x and some vertical distance y, right? So I just drew a right triangle. So I'm just going to draw that right triangle out just so I can see it a little bit clearer, right? And I know that this is a right triangle because I created this y by just dropping an altitude down, and that automatically is going to be 90 degrees. Right, so I have a right triangle, so I know that because I have a right triangle, I can always use my Pythagorean theorem. So I have a squared plus b squared equals c squared. My c squared value, my c value, corresponds with my hypotenuse, so that's the same as c. Right, so this is 1 squared, right? And then my legs, x and y, are going to be my a and b values, right? So this is x squared plus y squared equals 1 squared. I'm going to just simplify that a little bit more. So x squared plus y squared equals 1. And lo and behold, that equation looks pretty similar, right? That's the equation for our circle of the unit circle, right? So because this Pythagorean theorem is inherently linked with the unit circle, there has to be some kind of relationship between our trig functions that we learned about that deal with right triangles and this unit circle, right? There's something that's connecting these two. And so when we're thinking about drawing right triangles within our unit circle, we can start seeing what that connection is a little bit more clearly between triangles and trig functions and the unit circle, right? So in order to talk about this a little bit more clearly, we need to discuss some terminology, right? So when we draw a line from the center to a point on the circle, we call this a terminal point. So if I'm at the center of my circle and I draw a line to a point on my circle, this point is called the terminal point. And so that's just going to be an xy coordinate, right? This line going from the center to a point, to the terminal point, that's my radius, right? That's r equals 1 because I'm dealing with the unit circle, right? And so because this coordinate is x comma y, this is a general coordinate, right? I know that I'm moving x distance across. So this is x distance across. This is y distance up and down, right? And so this angle that I'm forming, I'm just going to call that the central angle, right? My reference angle theta. So let's define the relationship between the coordinate of the terminal point and our trig functions using the unit circle on the right. So if I am letting this be theta, right, sine of theta is going to be my opposite over hypotenuse. So this is going to be y over 1. Y over 1. And so if I just simplify that a little bit more, that's y. Okay. So because sine of theta is just simplifying down to y, right, I'm realizing that sine of theta has a connection with the y coordinate of my terminal point. So whatever theta is, it doesn't matter what the theta value is, right? Sine of that theta value is always going to be equivalent to the y coordinate of your terminal point. Let's try out cosine of theta, right? So for cosine of theta, we have adjacent over hypotenuse, so x over 1. And so if I simplify that a little bit more, that just becomes x, right? So just like how we said for sine of theta, right, how it corresponded to the y coordinate of the terminal point because it simplified down to just y, right? Cosine of theta is going to correspond with the x coordinate of your terminal point right over here. So whatever that x value is, right, it's going to correspond to cosine of theta. So tan of theta, right, is going to be my opposite over adjacent, so y over x. And now, in order to get cosecant, secant, cotangent, just take these ratios and then flip them, right? So my reciprocal of y is just going to be 1 over y. My reciprocal of x is going to be 1 over x. And then my reciprocal of y over x is going to be x over y. And so, using these specific values, right, or these specific ratios, they're not really values, that correspond with our trig functions, right, we can actually figure out at what point we're going to land on the circle at very specific angle measures of theta values. And we're going to be exploring that in our next section. So if you have any questions on this, as always, feel free to just email me, but good luck on your assignments.